Let's start today's topic. We have learned that bodies get charged on rubbing. A body may be negatively or positively charged. But have you ever wondered why a material gets charged on rubbing? Well, atoms are the building blocks of all the elements of this universe. But they are not charged because the amount of negative and positive charges contained in the body are equal. Thus, to charge a body, we need to add or remove one kind of charge. When one kind of charge exceeds or deficits in the body, it is said to be charged. In solids, some of the negatively charged electrons are loosely bound. On rubbing the body with another body, they transfer from one body to other. The body which loses the electrons has surplus number of positive charge, so it becomes positively charged. On the other hand, the body which gains these electrons becomes surplus in negative charge. As a result, it becomes negatively charged. So it is concluded that a body can be charged positively by losing some of its electron and negatively by gaining electrons. This is what happens when we rub a glass rod with silk. On rubbing, some of the electrons from the rod are transferred to the silk cloth. Thus, the rod gets positively charged and the silk gets negatively charged. This is very important to remember that no new charge is created in the process of rubbing. Another important point is that the number of electrons that are transferred is a very small fraction of the total number of electrons in the material body. This happens because rubbing results in transfer of less tightly bound electrons only in a material body. We can detect that two bodies are charged by bringing them close to each other. But is there any other way to detect a charged body? Yes, there is a simple apparatus to detect charge on a body. This apparatus is called gold leaf electroscope. A gold leaf electroscope consists of a vertical metal rod sealed inside a box. The metal rod has a metal knob at its top end outside the box. Two thin gold leaves are attached to the bottom end of the rod. Let's bring a charged object and touch the metal knob of the rod. What do you observe? Yes, the gold leaves diverge. Do you know why? Remember what happens when a charged rod is touched to an uncharged pith ball? Yes, the charge from the rod transfers to the pith ball. Similarly, when a charged object touches the metal knob at the top of the rod, charge flows to the leaves via metal rod. But why do the leaves diverge? Since charge of the same nature is transferred to both the leaves, they repel each other and diverge. The degree of divergence suggests about the amount of charge. Larger the charge, more is the divergence, and vice versa. You might want to know that you can make a simple electroscope at home too. You can use a thin aluminium curtain rod having ball ends for the purpose. We need a section of approximately 15 to 20 centimeters along with the ball end. Take a bottle of appropriate size having plastic cap in which this rod can be placed. Remember that the metal rod should be short enough to hang in air. Now make a hole in the plastic cap of the bottle through which the rod needs to be inserted. The size of the hole should be sufficient to fit the rod tightly. Insert the rod through the hole in the cap in such a way that the cut end should go inside the bottle and the ball end will remain outside the bottle. There should be a gap between the cap and the ball end. Now fold a small thin aluminium foil of about 5 cm in length in the middle. With the help of cellulose tape, fix it to the flattened end of the rod. This aluminium foil will act as the leaves of the electroscope. Now, it is time to use our electroscope. Rub a plastic comb or scale with dry hair and touch the ball end with it. What do you observe? Yes, the leaves of aluminium foil diverge. Can you explain why? Right, when the plastic comb is rubbed with hair, it got charged. When this charged object comes in contact with the metal ball, the charge gets transferred from the object to the leaves via metal rod. Since the charge of same nature is transferred to both the leaves, they repel each other. As a result, the leaves diverge. So what we have learned today is bodies get charged on rubbing. A body may be negatively or positively charged. Bodies are generally not charged because the amount of negative and positive charges contained in the body are equal. A body can be charged positively by losing some of its electrons and negatively by gaining electrons. No new charge is created in the process of rubbing. So the number of electrons that are transferred on rubbing is a very small fraction of the total number of electrons in the material body. Rubbing results in the transfer of less tightly bound electrons only in a material body. A simple apparatus called gold leaf electroscope is used to detect charge on a body. When the metal knob of the electroscope is touched by a charged body, similar charges transfer to both the leaves, so they repel each other and diverge. The degree of divergence suggests about the amount of charge. Larger the charge, more is the divergence, and vice versa. So that's all for today. Take care and keep learning.